welcome everyone. So I'm going to be looking at this question from S1 EdXL, taken from the June 2017 paper, question 3. Again, it will provide us with another template against which to practice our conditional probability question. So we're looking at a Venn diagram question with 3 different events, and we're given information that relates to the probability of those 3 different events. So we need to use that information and the properties of probability in order to solve for the unknown values R, S, T, P, and Q. All right, so let's have a go. So we're told that the probability of A is 0.5, the probability of B is 0.6, and the probability of C is 0.25. We're also told that B and C are independent. So we want to use generate as many equations as we can and then have a go at solving those equations. So since we have 1, 2, 3, 4, 5, we know that we can only solve this if we have 5 equations. So the number of unknowns must determine the number of equations in order to help us to solve them. So we need 5 equations at the minimum in order to solve these values. So we know that probability of A is 0.5. So we can, that tells us that R plus S is equal to 0.5. That's one equation. So let's continue from there. For probability of B is 0.6. So that will tell us that S plus T plus P must be equal to 0.6. That's our second equation. Then the probability of C is 0.25. So that tells us that P plus Q equal 0.25. That's our third equation. Next, we're told that B and C are independent, so the probability of the overlap will be equal to will be equal to the probability of the product of the 2 events. So B and C are independent. B overlaps with C gives us P. So P is equal to the probability of B times the probability of C. So that's equal to 0.6 multiplied by 0.25. So that would be equation 4. And the fifth equation is that the sum of the probabilities will add to 1. So that's R plus S plus T plus P plus Q plus 0.08 all adds up to 1. And that's the fifth equation. So from here, we're going to use backward substitution in order to solve the problem. So what that means is that we solve for one variable, use that in another equation, solve for another variable, use those 2 known variables to solve for a third, and so forth. So equation 4 immediately helps us to, with a starting point. We know that P is going to be equal to 0.6 times 0.25. All right, so that's going to be 0.12. Let's double check. 0.6 times 0.25, 0.15. And then we continue from there. Since I know what P is, I now can work out what Q is. So 0.15 plus Q equal 0.25. So this implies that Q is 0.10. Right? So we now have Q sorted. So I have P and I have Q, and we can look to now solve for another unknown. So that's sorted, that's sorted. Okay, so where are we going to go from here? So let's simplify the other remaining information. All right, so this has P in it, so I can swap it with my known value. So I still know that R plus S is equal to 0.5. So that's still known. Then now, I know what S is, I know what P is. P is 0.15. I can carry it over here and get 0.6 minus 0.15 to be 0.45. So S plus T is equal to 0.45. That's equation 2. And then the final one, I know P and Q added together. So P is 0.15, Q is 0.1, that's 0.25. So R plus S plus T is equal to 1. So 1 minus 0.08 minus 0.25, so 0.67. All right, so that's my remaining information. I'm going to use that in order to now solve for R, S, and T. So one way now is that we could add equation 1 and equation 2. So if we add 1 and 2, so 1 plus 2 will give me R plus 2S plus T equal 0.95. Now compare R plus 2S plus T with R plus S plus T equal 0.67. That means that if I were to subtract, and let's call that 4, if I were to subtract equation 3 from equation 4, I'm going to be left with S. So S is going to be 0.95 minus 0.67. All right. So 0.95 minus 0.67, that gives me 0.28. So let's look at what we have so far. We have P to be 0.15. We have Q to be 0.10. We have S to be 0.28. And then with that now I can easily calculate R. R will be 0.5 minus 0.28, which is 0.22. And then once I know R, I will know T. So T will be 0.45 minus S. So 0.28 from 0.45, that would be 0.17. All right, so that should complete the part of solving for the individual values of R, S, T, P, and Q. Okay, so notice again, just to reflect on the approach. The approach was using the properties of probability along with the information given to us in the question. We went about to set up five equations, and then saw how best we could to work out the unknown values. So from here, we're going to have a go at evaluating the conditional probability that has been presented to us. Okay, so in part B, we're asked to find the probability of B given the probability of A union C. So the probability of B given the probability of A union C. So here, by formula, this will be the overlap, the probability of B intersect A union C, divided by the restriction A union C. So the overlap, B intersecting with A union C, the overlap will be this region here. All right. So that is T. So S and P, we've worked out S to be 0.28. And we add that to P, which is 0.15. And the restriction is A union C, which is R with S and P with Q all added together. So the only thing, so R with S is going to be 0.28 plus 0.22. And then we're going to add to that P with Q, 0.15 plus 0.10. And then we're going to evaluate that as best as we can. So we can use a calculator here. 0.28 plus 0.15 divided by 0.28 plus 0.22 plus 0.15 plus 0.1, and that should give us 0.573 recurring. So we have 0.573 to 3 decimal places. All right, so a fairly interesting question, which I thought might be thought-provoking in your preparation for conditional probability.